Definition of the inverse function. A function, let f and g be two functions, such that f composed of g, with g of x equals x, for every x in the domain of g, and g of f of x equals x for every x in the domain of f. All this is saying is this: if g basically goes from the range to the domain, so as I'm going to pick up an x value here, it's going to take it to something over here, so that's what g does. And then f picks up whatever that value is and takes it back to the original. So in other words, the issue is you always end up where you started out. I started at x, I ended up at x. Whatever x happens to be. This would say if f, you're going to start here at x, it takes you to something on this side, and then g is going to pick up whatever that thing is, and it brings it back to the original. It goes full circle. Wherever you start out is where you end up. If that's the case, then the two functions are inverses of each other. So it says it doesn't matter where you start out, whether you start in the range and then flip to the domain and then back to the range, you still end up at the same point where you started. So it's like, for me to go back east, I start at Phoenix, go to Washington, D.C., come back to here. So that's an inverse function. My brother-in-law starts in Washington, D.C., comes to here, goes back to Washington, D.C. So at which point it doesn't matter where you start, it's that you end up where you started out. That's the inverse function. That's the purpose of the inverse function. It's your round-trip ticket. Get you back to the original starting point. And that says that what happens is this. If I compose f with g, that f of g of x is equal to x. So that if I take a look where f of x is 2x minus 3, and f inverse is x plus 2, if I compose f inverse and f, so f is the inside, f inverse is the outside, so that says in the inverse function, which is x plus 3 over 2, I'm going to insert the original function, which is f of x, which is 2x plus 3. When I simplify, I end up at the value where I started out. So I started at x, I ended up at x. Same thing here. If I compose f of f inverse, that says I'm starting at x and I'm putting the inverse in the original function in place of f. So it becomes 2 times the inverse function minus 3. When you simplify it, it ends up being x. It says I started at x, I ended up at x. There was a problem we used to have on the college algebra exam over at ASU, which looks something like this. What is f of f inverse of 35? What does it have to be? 35. You started at 35, where should you end up? 35. You end up where you started out. That was a tough one. And then we did give them the function, and did give them, and some people actually went and did all the calculations. But it just there that says the inverse and the function cancel each other out, and what you're left with what you started out with. No, I didn't hear you. I'm sorry.
What's the point in doing the equation then?
Because you want the rule. And in this particular instance, it didn't matter whether or not I had the rule. But what you do is you want the function that's going to bring you back. Now remember, the inverse function is the undo button. And for those of you who had logarithms in 120, is that the logarithmic function is the inverse of the exponential function. So it's there to develop the relationship between functions. That says if I need to undo something, what do I use? I use his inverse, whatever that happens to be. But you actually want to go after the rule. So on this guy it says, verify that the function f and g are inverses of each other, showing that f of g of x equals x and g of f of x equals x. Now here's the good news, if there's any good news to all of this. And that is that if I can prove it for one, it's true for the other. You don't have to do both. When we're looking at algebra and the kind of stuff that we do in algebra and the kind of functions we have in algebra, I don't need to check to see that both sides are true. If one of them is true, then they're both true. So we look at f of g of x. Now f of g of x has to be x. In other words, I started out at x, I need to end up at x. So this says in the function f, wherever there's an x, I put the function g. So that says that f of g of x is going to be, take out the x, and put in g, what you end up with is the square root of x plus 2 minus 2 squared. Plus 2 minus 2 adds to 0. So you get the square root of x squared, and the square root of x squared is x, and it verifies. That tells me now if I do g of f, it's also going to verify. So if one did, so will the other. So you only have to really check one. This is g of f of x. So that says in the function g, you're going to pull out x and put in the function f of x. So that says in g, I want to look at the square root of x plus 2. X is the function f, and f happens to be x minus 2 the quantity squared. X minus 2 the quantity squared, so I'm going to have the square root of x minus 2 the quantity squared plus 2. And what's the square root of x minus 2 the quantity squared? X minus 2, because they really are inverses of each other. One does the other. Plus 2, and minus 2 plus 2 is 0, and it's x, and it verifies. And it should, because the other one did.